Now your sound is quite clear, sir. You may continue.
Yeah. So the sixth case study, which I will share with you briefly, that is for Sentinel-1 SAR data and Sentinel-2 multispectral satellite data. We utilize this two data for finding out the electrical conductivity of the soil. So before the electrical conductivity cannot be determined directly, but we can have indirect relationship with the EC, because EC, electrical conductivity of any soil, depend upon two parameters. First is the moisture parameter of the soil, how much moisture is there in the soil. As you know that as the water content will increase, the uh, conductivity will also increase. The second thing is that as the quality of soil, that is the content of salt in the soil, will increase, the electrical conductivity will increase. So our aim was to find out the salinity of the soil. Why salinity is much important parameter? Again, the salinity of the soil, as we use different fertilizers in the soil, with time the soil tends to become saline. And if the soil reaches a salinity level which is above a certain threshold, then the soil is of bad quality. There you will not be able to grow any type of crop. Also, you will not be the water will not percolate much inside, and a lot of damming will be there. The It will create a marshy land. So in Punjab, the salinity is one of the major problem, because Punjab was earlier a wheat growing state, but now with the green revolution and the cost of rice and many other economic factor, l- Punjab people started to grow rice in much larger quantities. The rice need more water, more fertilizer, and because of that, what happened that the soil in many region of the Punjab turned saline, and because of that, there is a problem in many parts of Punjab. In Punjab, there is a very big problem. Some parts of Punjab are less water is available, and in some part of Punjab, marshy lands have formed. So, two distinct type of thing is available in Punjab state itself. And if we monitor the salinity of the soil continuously, then we can take measures at the right time to change the quality of the soil, or we can take the measure to decrease the salinity. We can reduce the use of some type of fertilizer and increase this use of other type of fertilizer to counteract the action of the earlier fertilizer, and the salinity will reduce. So these graphs here, so uh, this graphs here shows the relationship between the EC of the soil and the backscatter of the satellite data. And we can see that there is a high correlation between the EC and the backscatter of the uh, SAR data, and that is Sentinel-1 data. So I will skip all these things, and I will come to more. I will skip this case study very fast, because we have to cover the another aspect, that is scatter data and snow cover part also. So we use Sentinel-1 SAR data and Sentinel-2 data, that is multispectral optical data. The data were pre-processed, and backscattering parameter from the SAR data were used. Also, the NDSI image, NDSI means the normalized difference salinity index, was used to develop a model. This model correlate both the data and give us from the soil field we use the soil moisture data, electrical conductivity, and the temperature data. For some points we measured the electrical conductivity, and the soil moisture data was used so that we can find out that whatever change is there in the field is not because of the soil moisture. So we use the soil moisture data also, so that we can count we can find out how much there is a change in the EC due to the soil moisture and how much it is due to the salinity aspect of the soil moisture. So the results clearly show that a very good correlation was established, and around uh, 95% accuracy was found for the this model, and we were successfully able to estimate the EC for the entire region, because for estimating the EC for entire Rupnagar area with the field data is would have been a very hectic process. So this model, this also used a least square model, regression model, and using this regression model, we were able to correlate the backscatter of the satellite with help of some of the field data. We were able to calculate the electrical conductivity of the field. So you can see that some of the regions are having very high electrical conductivity, and electrical conductivity which is represented in Siemens per centimeter. So this area is near the river where the moisture will be high, and also so that is one of the obvious thing, because where the moisture will be high, there the electrical conductivity is going to increase. But if we see this lower region here, the moisture is uh, low, then also EC is high, which suggests that the soil is turning into saline part. So this estimation of EC could indirectly lead us toward the soil salinity part. Then uh, we also tried to find out a relationship between the soil organic carbon content and the satellite backscatter and the field data. The field data was collected from several sites, and those were analyzed for the organic carbon content. Here I want to stress this multispectral data and hyperspectral optical data are very much useful in finding out the organic carbon content of the soil. But it was very few studies have been conducted to estimate the organic carbon content using the satellite backscatter or the SAR data. So here also two methods, the SAR data was taken, and the backscatter in both VV and VH polarization was used, and the optical data was used from the Sentinel to mask out the area which are uh, not open fields. So we estimated the organic carbon content only over the open agricultural fields, because when you are doing the modeling, and if you add the use the entire data, then what will happen is that the area which are not directly related to organic carbon content, that is urban area and other areas vegetation, they will induce lot of error into the modeling. So first step is to mask out the areas where which are urban and other build up areas, and heavy vegetated areas. And here also we use the OLS technique. And finally the uh, after training at the training phase we achieved the accuracy of 99%, and at the test phase we were able to get the accuracy of 88%. 88% may seems a little bit lower, but this was much higher than any other method. And here we used two type of uh, equations. One is the random forest regression and another is the ordinary least square regression. So if we compare the accuracy of these two methods as compared to the other commercialized satellite data and other models which were used by different scientists over the period of time, uh, uh, and two study, Zhao et al. 2020 used the random forest and the boosted regression tree method, and they achieved an accuracy of 75%, and we were able to achieve the accuracy with random forest around 88%. The accuracy difference is because we use the field data, that is of for the organic carbon content, then the soil moisture data also, and the EC data also. So if we use all these three data, then our accuracy increases. Although in Java et al. They used only the backscatter and some field data. So second study was from Yang and Gao. They use structural equation modeling, SEM modeling, and they were able to get accuracy of 66%. So our model performed better than any of these two models when we used the field data and also the moisture and electrical conductivity data along with the organic carbon data. And this was the final map which was prepared for the estimated organic carbon content for the Roopnagar. Here we this the upper region was masked out because they contain we didn't have any field data for that area. So now coming to SCAT-SET 1, and it is about the cryospheric study. There are applications of cryospheric sciences with the simple SAR data or simple method, DINSAR method, but I have not covered that. I have used different to give you a different application perspective. I have used this is I will be talking about this scatterometers. So what is a scatterometer? Scatterometer are also microwave sensors which work in microwave region, but they didn't have a source of their own illumination. They collect the information which are transmitted. Different earth object transmits different electromagnetic waves, and this scatterometer captures those electromagnetic waves in microwave region. So SCATSat 1 is a Ku-band satellite which was launched by ISRO, and it is a Ku-band satellite, works in 13.5 gigahertz band, and launched was on 26 September 2016 by ISRO. Enhanced spatial resolution data comes at 2.2 kilometer. So there is a trade-off between two resolutions here. The SAR, as if you remember, when I was talking about the synthetic aperture radars, the resolution was in the range of 20 meters, 10 meters, and even the commercial satellites are available at 2 meters, 1 meters ground resolution. But this scatterometer is available at a much lower resolution, and even if we enhance the resolution, if we achieve a few kilometers of the uh, resolution. So here we have a 2.2 kilometer, but there is another advantage of scatterometer. The scatterometer has a better radiometric resolution, uh, or you can say spectral resolution. It has a better ability to distinguish between different objects which are present in the ground in comparison to simple synthetic aperture radar. So this data comes in two polarization, HH and VV. then the data products are given at different levels, level 1 to level 4. We'll see different what is this level mean. And coverage is global level daily update on the condition of atmospheric conditions, oceanographic, agriculture, and cryospheric parameters. So coverage is global, data is available daily. So this is another advantage of using scatterometers, because the Sentinel data is available every 12 days. This data is available daily. So when the data, the repeativity is more, the resolution tends to decrease for the any of the remote sensing satellite. Like in case of Landsat, the repeativity is around 30 days and the resolution is 30 meter. But with the modest data where the repeativity is daily, you get a daily data, the resolution is 500 meters. Why? Because you have to place the satellite at much higher altitudes to cover the earth on a daily basis. So here the resolution, the spatial resolution decreases. Now coming to the different applications of this SCATSAT1 product. So we have wind product, we have ice cover product, we have brightness temperature product, and upwelling index, sigma naught vertical, sigma naught horizontal, and analyzed wind at a wind speed. So scatterometers were basically developed first to study the wind velocities. Then when we have the data, that is the primary application of any scatterometer which are sent in the space. But uh, we can use it to study the ocean currents. Secondly, we can use it for cryospheric study, because we have the data, we have the backscattering signals. So when we have backscattering, we can use it to identify different features. We can also use the scatterometer to find out the leaf area index and the vegetation information. Some people have also used it for finding out the crop type. So there are a lot of application along with the primary application, that is finding out the wind velocity. So these are different level of data. L1B, level 1 is L1B data, you get a sigma naught and the resolution is 6 into 30 kilometer. And in level 4 product, which has a application in nominal wind calculation. So for wind speed and direction, you can use this data. Level 2 data you can use for cyclone and weather forecasting. Level 3 data is used for weather forecasting, monitoring, and prediction of natural hazards. And level 4 data, which is enhanced resolution data, is usually used for land application, atmospheric, cryosphere, rice crop phenology, and predictions, different type of predictions. The graded data also comes at 25 into 25 kilometer resolution for wind speed vectors. Wind vectors means which direction the wind is blowing. The weather forecasting, monitoring, cyclone prediction, for all this 6.25 into 6.25 kilometer resolution, and at 25 into 25 kilometer resolution, this data comes. These are the different available data which you can easily download from ISRO's website. So coming to the application part, ocean dynamic, cryosphere, agriculture, and land hydrology are the major uh, field where this data has been utilized. And along with the additional data you can see here that some IMD data is used for monitoring and prediction of hazard, along with the SCATSAT data. And a method here you can see different models are also listed, which people have already worked upon. This is a new data, so this data is still very unexplored, and lot of applications are coming. Recently we published a paper for use of scattered data for cryospheric application for finding the snow cover, monitoring, and even at the cloudy conditions. So I will come to that. So cryospheric application, this type of product you will find, and for monitoring the Antarctic and Arctic region, the South Pole and North Pole of globe. Also, this data is being used. So detection of snow cover variation with scattered one data. So snow is a key climatic index, has a direct impact on global heat budget and planetary albedo. So we know that the snow reflects more of the solar incoming radiation. So if the snow cover from the globe, if we remove those snow cover, what will happen? The earth will heat up much more because the rock masses and the soil masses absorbs the solar radiation, the heat from the sun, and then at night time they radiate it as a long wave radiation which do not pass through our atmospheric uh, atmosphere and heat up the earth's surface. But if during the daytime itself the snow cover is present, what it does is it reflects most of the incoming solar radiations. So incoming solar radiation, the snow reflects almost around 95 to 99% depending upon the uh, type of snow. Type of snow means age of snow. If the snow is fresh, it can reflect up to 99% of the incoming solar radiation, and if the snow is a little bit older, then it will reflect around 95% of the incoming solar radiation. So this lead to a lower heat absorption by the earth's surface, and thus snow is not only important for water resources, it is also important for global heat budget. So over Indian Himalaya, snow melt provide water for irrigation, drinking, and power generation purpose. Despite the various benefit, heavy snow storm led to snow avalanches during the winter and flash flood due to rapid snow melt during the spring period. A scatterometer is a microwave radar instrument designed specifically for ocean application. Although due to strong sensitivity to the wetness of the snow, it has been extensively used for cryospheric applications. So these are the data that we generated using for 2017 and 18, 16, 17 and 17, 18. We were able to, for the study area was Himachal Pradesh. You can see that almost half of the Himachal Pradesh, the upper northern part, northeastern part of the Himachal Pradesh, is the area which has a lot of snow cover. So we utilize this scat set data and different classification techniques, unsupervised and supervised classification techniques, to find out the snow cover for the 2 year 2016-17 and 18. October November means the change between the October and November month. November December means the area which are changed between November and December. So, coming to this particular picture, if we see that December 16 and January 17, the snow cover is large, and during the same period in 18, 17, 18, the snow area has decreased, and it has decreased at almost all the elevation range. So decreased at all the elevation range. At higher altitude, it was decreased less, but at lower altitude, it was much higher. So we use the ANN PCC method for uh, finding out the snow cover area, and then uh, finding out the change map. And here is a one slide which says detection of snow cover variation with scattersun set 1 under cloudy condition. Here we see a modest data. Modest data is acquired daily. Then you can see if what happens if the data is acquired daily. Lot of areas are under snow, under cloud cover. So in modis, what happens that they give you two type of composite images: 8-day composite and 16-day composite. In 8-day composite and 16-day composite, what they do is they take the multiple daily images for the 8 days or 16 days, and suppose cloud is present over x pixel today, and in the next image the cloud moves, because you everyone knows that cloud is not a stagnant feature, it moves from one area to another area. Today one area if it is clouded, it may happen that in next image the cloud can move to another area. So whatever pixels are clear, they pick up those pixels for from the 18 days or 16 days. So in 16 days image you will have less probability that entire a particular portion will be covered by the snow for the that entire one particular region will be covered by cloud for that entire duration. But even if we use this method to find out a best quality image which is not covered with the cloud, then also it is not possible, because in hilly regions some of the areas may get covered by the cloud for entire 16-day duration. So even in the composite images we have cloud present. So this A image is a modest data which is daily data, and when we classify this and we see that some regions are snow and this is the cloud region, and these are the what is called barren here is non snow cloud area, and this one is the scat set 1 data. And when we classify this scat set data with the ANN model, we get a two binary image. One is snowy area and another is the non-snow area. So this is snow and non-snow, and using the composite data mod 10 data, it is a snow product of the modis which is given freely, and it is given on a 16-day basis. So 16 days modis data is used for this preparation of this data. So there is a good correlation between a SCAT 1 classified snow cover map and modest composite data. However, when we use a daily data, then we see lot of cloud present. So SCAT 1, so this is a very important study which suggests that SCAT 1 could be used to prepare a daily snow cover map even in the cloudy condition, which is not possible with any of the optical data. Then we also used there is a unique feature of optical data that cannot be met with the uh, SCAT data. SCAT data cannot classify the vegetation with the same accuracy as that of an optical data. So can we use the optical data and the scatterometer data together and fuse them to get a third data set, which is a fused data for finding out a these ground feature much more clearer during the cloudy condition. Because if we see the modest data is available as a composite image where the cloud is less, and if we go for daily data, then there will be lot of areas which will be covered with the cloud and we will not be able to get the ground information. If we scat set snow, it is okay that we can use the scat set data for finding out the daily snow cover content, but we cannot use scat set data to find out the daily uh, vegetation cover with the same accuracy. So in this study, we fuse the modest daily data and scatterset one daily data to get a third uh, synthetic product, which we can use for getting the snow and vegetation map. So coming to the points here, remote sensing via optical imaging has a great impact on the continuous monitoring and mapping of the Earth's surface changes, but the optical data often suffer from the cloud contaminated pixel, especially in case of mountains, a mountainous region, which may restrict the application range of the optical dataset. Spectrometer satellite SCAT-1 has the potential of penetrating the cloud up to a great extent and facilitate a realization of characteristics of an object over the land surface. So we have focused on nearest neighborhood based fusion of MODIS and SCAT-1 data to generate a cloud-free image, which could be used for applications where SCAT-1 alone cannot work much efficiently. To understand the overall applicability, the output fuse data has also been classified using the ANN method, uh, which is a very well defined and widely used classifier. Both satellite data, MODIS and SCATSET are freely available at global level, and thus it can attract the interest of researchers. So here, if you see the figure A, it is the SCATSET1 data, figure B is a cloudy MODIS data, and figure C is a fused data. Means we use the SCATSET1 and the MODIS data to fuse and generate the image C. D is the C is the fractional classified fused data. D is the binary fused image. Means we used it to classify two features, snow and non-snow region. And F is the mod 2 classified image. So this image we can see clearly that lot of cloud is present, but this image and this image, when the fused image of the Mortis and Scatsit one was used, we got a better resolution, we got a better classified output from which we can find out the snow and non-snow region. And this was also, I think it is not included here, but the same data was also used to find out the vegetation part also. So my point is that uh, along with the SCATSET1 data, if we fuse the SCATSET in MODIS data, we get a better resolution data, and the cloud is also removed. So if we compare figure D and figure G, we'll see that there is not much difference in the output. So figure D is from the fuse data, and figure G is the Martin data, which is a um, composite image. So this clearly gives us the advantage of this modest data, the fuse data. Then we also use the unsupervised classification of dual polarized HH and VV SCATSET1 data. SCATSET1 offer enhanced spatial resolution 2 km data product in form of sigma naught and gamma naught. Both forms are available in two polarization mode, HH and VV. Uh, uh, these were used to find out the backscatter coefficient over snow cover region. To test the efficiency, we implemented the unsupervised classification on both the backscatter coefficient. The K mean as unsupervised classifier takes the advantage of independency of user input. So it is not dependent upon the user input. So earlier I said that we have used the ANN model So even if we don't go for complicated models like ANN, we can use simple unsupervised classification with the SCAT-1 data, and we can achieve a good quality results, which is shown in this figure. So if we see in this figure the classified data of hello, can we mute the participants for now? The A is the A is the A is the scat set 1 sigma not classified, and B is the gamma not classified image, and C is the NDSI map generated from the MODIS data. So we can see that there is a good correlation between these two dataset and the sigma not classified and the gamma not classified and the NDSI image. So it is uh, we concluded that even using a simple unsupervised classification method, the accuracy achieved is good from the scat set data. Then another very important parameter is the retrieval of brightness temperature from the scat set 1. So scat set 1, the brightness temperature is already provided for with as a level 4 data for the entire globe, derived from the SCATSET data, but that data still needs some processing to that data is given in some DN values, which need some empirical equation to be applied in that data to find out the exact brightness temperature from both VV and HH polarization. So just a second. So the brightness temperature, which is written here as TB, is considered as the fundamental climatic data record that governs the radiance traveling toward the satellite from the top of the atmosphere. The optical sensor plays a vital role in retrieval of brightness temperature, but they are affected by clouds. Just as said that Landsat has a thermal band which can be used to calculate the brightness temperature at 100-meter resolution. Then MODIS has the thermal band. MODIS data can be used for calculation of daily brightness temperature. But if we go for daily brightness temperature using the MODIS data, then what will happen is that lot of the areas come under the cloud, especially in the mountainous region, because mountainous region, if we see Himalaya, you will find that some of the portion will be covered by cloud at daily basis. Yeah, all the seasons, even the most clearer season is the winter, where the before the winter, not exactly the summer also, because in summer there will be snowfall, and in the late winters also there will be snowfall after October. So from October to April, you will not find a single image of MODIS, daily image of MODIS, where there is a no cloud or less cloud. So this to monitor the daily temperature, the MODIS data has its limitation, so which can be overcome using the SCATSET1 data. The SCATSET1 also provide the brightness temperature for the slice and footprint that are derived from the scatterometer noise measurement expressed in the unit of temperature, that is degree Kelvin. The SCATSET1 level 4 brightness temperature available at two different polarization mode, that is horizontal and vertical. The main objective of this study is to retrieve the brightness temperature at both the polarization over the part of Western Himalaya, Himachal Pradesh, using the SCATSET-1 backscatter, and validating the result using the MODIS data and different field data. So what we did is that we took the Himachal Pradesh and took the brightness temperature using the SCATSET-1 data, and also and compared it with the modest brightness temperature. So modest brightness temperature, why we selected that data? Because that data has already been validated by many scientists over different portions of all over the world. So modest data has uh, a particular validity accuracy which is well studied. So if we can correlate the SCATSET1 data with the MODIS data and find out how much these two data correlates, then we'll have an alternative to find the brightness temperature on a daily basis. On and using the MODIS data, daily finding the daily temperature is.
Participants are requested to mute their mic. All the participants are requested to mute their mic.
I think administrator can mute.
Yeah, yeah. Mr. Ravi, please you can mute all the participant except Dr. Deep Kamal.
Yeah. So uh, we use the SCATSET1 data and modest brightness temperature and compared them and found out that what is the uh, correlation between these two data. So uh, the correlation that we were able to retrieve for HH polarization was 83%, and for vertical VV polarization was 83.11. A slight difference was there between these two polarization mode in the accuracy, and the number of pixels which were compared were around 25,000 pixel. So using a large sample, we were able to correlate these two temperature data and found out that the accuracy is very high. The difference in the accuracy or the 83% accuracy, one reason could be the lower resolution of the brightness temperature, which is retrieved by the uh, SCATSET1 data, because the brightness temperature from MODIS data is available at 500 meters resolution, 500 by 500 meter pixel resolution, and the SCATSET1 data, the resolution of the SCATSET1 data is around 2.2 kilometers. So when we average the brightness temperature, one scat set will have four modest pixel, so there is a slight averaging out of the brightness temperature, so the accuracy may reduce because of this region also. So I think this is all. I can summarize it. For snow and ice application, SCATSET1 plays a crucial role to derive the snow cover map or the sea ice extent. We have tested it for the Himalayan region, but people have are using it for monitoring the Arctic and Antarctic region, which is very important also for monitoring of the icebergs in the sea. Because if we can monitor the icebergs, we can icebergs may play a very devastating role for the different ships and other things. So monitoring of icebergs are also very important. And the number of icebergs, measurement of the numbers of icebergs are also very important, because icebergs is formed when the ice breaks from the polar regions, and that is Arctic and Antarctic. So why those are ice breaks? Because in the increase in the temperature. So monitoring of icebergs and other things are also very important parameters, which scientific community studies at a very high accuracy, with very high accuracy. So SCATSat 1 offer various advantages such as day and night operational capacity, applicable functional under cloudy condition, global coverage, worth. And even if you use one data, two or three data will be used to cover the entire area. So you need to process less amount of data to find out some information over for a regional study. So this low resolution data is very good for uh, regional studies. So, coming to the next point, availability of range of pre-processed data. Here, all the pre-processed data is listed, and it is best thing is it is freely accessible at a daily basis. So, data for today will be updated in the servers the next very day. So you can download the data directly and use it for various applications.
Excuse me, sir. Can we
Yes.
compare the brightest temperature data from the microwave sensor to this sensor, sir?
Yes, that we did here. We took the SCATSat data and calculated the brightness temperature image is given directly. You can download the brightness temperature data, but this brightness temperature has not never been verified in the field. So we took the modest brightness temperature data and compared it with the brightness temperature which was derived from the SCATSat one data. So the comparison, the results clearly show that the data has a very high correlation.
Sir, one more question. When we are doing in the soil moisture content, so you have told that regression method. Can we use advanced that machine learning? Can we apply for that, sir?
Yes,
Algorithm?
yes, machine learning. We are using machine learning also, but why we use regression method is because we wanted to keep the model simple enough, which can be used by many researchers. Because see, frankly speaking, for the last 2 years, I am working in microwave remote sensing. Why
Yeah.
I left microwave remote sensing? Because when you see the different papers and other things which people put for microwave, they make the paper so complicated that a researcher who is starting in a microwave field will see it and will be discouraged to use the microwave data. And this is the main reason why in India and all over the globe microwave remote sensing was not that much popular. But now and go 10 year back, there were no commercial software for processing the data, unless and until even the gamma, which is a very popular software. If you not all the researchers are coding expert, and even if you are a coding expert, the another problem was that with the microwave data at few years back is that you processed everything. It took 5 6 days for data processing, and after you found out that you missed one parameter, and every processing you have to repeat. So if we make any model as simple as possible, then the application or the people will be using it more oftenly. So our aim was to use the simple regression method to find out the accuracy. But yet, yes, definitely we can use AI and machine learning, deep learning methods, and we are also using that. That is under progress. So
Okay. Okay. Sir, one more request, sir. Is
yes,
it
please.
possible, can you share your contact details, sir? So if any further doubts, we can contact you. If organizer is also agrees. It's,
Yes, my contact detail is email is right in the slide. And the email you can note it down from here, and I will share my mobile number also. I don't have any issue.
I will be sharing all the details of experts to the participants. So you can contact
okay.
them.
Thank you. Thank you.
Okay.
Yeah.
And I will be sharing this recording will be shared of all the sessions. Recording will be shared to you.
Yeah, I have also shared my mobile number. The email is also in the this readkamal at the rate iitrpr.ac.in. That is available to everyone. Yeah, so any other questions, please, you can ask. Hello.
Hello. Good afternoon, sir.
Yes.
Sir, if we want to do rice or paddy classification
Mm-hmm.
at level, so will it be sufficient if we go with the Sentinel-2, that is the optical data,
Mm-hmm.
or we need to go for Sentinel-1, that is the SAR data?
Rice and paddy.
Yes, sir.
So see, rice and these are two are grown at same season or a different season. I think it is grown in a different seasons.
Yes,
So
sir.
y- yeah, so you can use both of the data. Sentinel 2 also you can use, because the field where rice is grown, after that there will be some gap, so you will be
Yes.
able to find out which area has seen the change in the plantation. Also there will be slight change in the reflectance property of these features. Also the brightness, the back scattering of both the crops will be little bit different.
Yes.
So I have not used it for classification, but with my experience, I can say optical data will be much more useful only for distinguishing the type of the crop.
Okay, sir. After classification, in order to estimate the yield,
Mhm.
so is it Sentinel-2 is sufficient, or we need to go for microwave data?
Yeah, yield depend upon several things. While I am studying the different soil health parameter, the
Yes.
ultimate goal is to estimate the yield. Till now,
Yes.
people have used the microwave data and optical data for retrieving the yield of the crops, uh,
Mm.
to find out the health of the crop. Health of the
Mm.
crop is also ignored, just to find out the mass of the crop, and then using an empirical equation that if this much is the mass of a particular crop area and this is the area, then in one hectare or in 1 acre you can find out this much of yield. So
Yes.
ultimately the yield will be x amount. But
Okay.
using the AI and machine learning techniques,
Mm.
now people, I've been working with one of my colleague in computer science department. So
Okay.
we were able to just feed the data with optical satellite data and
Mm.
estimate the yield at a much better accuracy. There we didn't utilize any data. Now the accuracy that we got was around 60 to 70%. Now what I am thinking, or what would be better strategy, is to feed the algorithm with various type of data, such as the soil health parameter, because if the quality of the soil is better, the yield will be higher. If the
Yes.
moisture throughout the growing season is better, if the organic carbon content is high, then the yield of those area will be higher than the yield of area which are in the drought season. So including these parameters in the model will definitely increase the accuracy of the model.
Yes.